Nice to meet you to this new episode of WIGBIT. In this assembly course we have the electronical counter that we programmed last time, and you can see here the counter is running from here. This is the 0 bit, the 1 bit, 2, 4, 8, 16, what did I say? 1, 2, 4, 8, 16, 32, 64, 128. These are the bits where the counter is running, and you can see a binary counter. We cannot read by the eyes what is this for a number. So I connecting here a 7-segment, and this 7-segment LED is parallel connected to the bits. First with the bit 0, then 1, 2, 3, 4, 5, 6, 7, and the dot is 8. And you can see there are no viewable numbers. The counter is running. This is the counter, but you cannot recognize the number. It's not a number. It's something. Yeah. And we would like to make a bit button today. A bit button is this button for the display that it shows the number what is the counter. That means it's translating from this binary to a viewable number like 0, 1, 2, 3 and so on. Yeah, what we can see in the display also here, this machine here is a programmer. It costs like 21 euros. You mean in America it really costs $22 or so. I bought it at Amazon. It's not an advertisement, but good cheap programmers exist for less money. And this controller board with the ATM328P, you have here a socket. You can release it and change the IC. Yeah, what we see here is the board B, and I think so it's B. Yeah, it's board B B0 till board B7, and the board D. The board C, the green one, blinky LED, is the board C. What I would like to do now is I would like to make a counter, but not a counter that counts 1, 2, 3, 4, 5 and so on. We're making a counter that making a countdown. It's 9, 8, 7, 6 and so on. Yeah. Yeah. Now we have a watch on the assembly code.
Now what we're gonna see here is the assembly program, but our program sounds like here is assembly, and it's called like 7-segment like counter assembly, and we have here today the 11th May and 11th May for all my viewers in America. I write this here, and for Windows, for Linux, we have here a Linux system, operation system, and we have here the history is the 11th, 5th and 2023. We say 7-segment countdown. Countdown, so that's correct. And we have here the thing, we have here the counter. The counter is here, counter 2, and we should make status. We make a register. We defined 7-segment. 7-segment is R23. 7-segment display. This is a LED display. LED display. Okay, we have that here. we're using this 7 segment, or we say LED underline 7 segment. This is correct. And the counter LED, we let it be, and here the 7 segment, what we would like to show. In the 7 segment LED, we put in here for a while, and we say this is the subprogram number 3. And first we need to make a button, numbers and names. I say numbers and names is a good thing. We have here that we doing here the 7 segment, 7 segment bit button. What does that mean? We have here things like the stroke 7 segment. We have here here is the number A, here is the A, and we have here we have the vertical, and here we have the vertical, and we have a vertical here. Looks not good. And then we have the next line. We have here also vertical, then some strokes, and then a vertical, and then we have here I cannot make it. It's very difficult. We have here no strokes. We have here this, and then we have here this vertical and the vertical, and we have here should I make it this? No. Okay, here we have it, and now we would like to give them a number, but there is no number. It's a A, and here it's the B, here is the C, and here is the D. I'm putting this, here is the D. Oh, my computer. D, and here is a E, but E, F. Oh, we're doing this like this, and here we have the A. Here's the A, not here. And inside is the G. That means we can put it here, the G. Here is the G that you can understand, and the dot is the F. The point is what we have G, H. It's H, okay? So we have the bit numbers here, and what are the bit numbers for A? A is bit is 0. We have here the bit list, bit button. We have here the bit button, and we have here the B is number 1, and the C is number 2, and so on. And the D is number C, D number 3, D, E is 4, and F it's 5, A, B, C, D, E, F, G, and G is 6. How can that be? Yes, it's correct. And then we have here the G, and we have here the H is the dot. It's the bit number 7. So we say equal, LED, LED, A, no, LED 0. LED 0 is D0 is 0B. And now we have the intro. Look at the mouse. We have here the A, the B, the C, the D, the E, and the F for 0. There is the O, yeah? 0. That means the H is not, and G is not, and all others are 1s. Is that correct? 2, 4, 6, 7, 8, 9, 10. So that's correct. Number 0. Number 0. Okay. You see that? We have here late 7. Late 7 segment. This is okay. 0. And so we go on. We do that with the LED. 7 segment 1. It's 0B00. And B and C must be shine. Yeah, B and C must be a light on. This is the number 1. That means we have here. Now we would like to make here information for me. What's going on, and G, F, E, D, C, B, A. These are the bits. Yeah. We have B and C, B and C, B and C. B and C must be 1, and this is number 1. Number 1. And so on. Giving the 2. LED 7 sec is 2. It's complicated. Now we have the A, B, G, E, D. A, B, G, E, G. G, A, B, G. A, B, G, E. A, B, G, E. E. And D. A, B, G, E, D. A, B, G, E, D. This is number 2. This is the bit button for number 2. Number 2. Equal LED 7 sec 3. How is 3? 3? I cannot write the numbers. What is 3? 3 is A, B, G, C, D. A, B, G, 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 F not, F not, E not, D, yes, C, yes, B, yes, A, yes. And this is the bit button for number 3. 2, 3. So equal LED 7 sec 4 is 0 B. What is 4? 4 it's F, FGB. 7, what is 4? Very funny. It's G. It's G. That's correct. Then F. That's correct. Then E. No. Then D. No. Then C. Yes. Then B. Yes. And A. No. Well, this is a complicated character. Number 4. And we have here LED 7sec 5. If something is wrong, please tell me that. What is 5? 5 is A, F, G, C, D. A, F, F, G, A, B, C, D, E, F, G, H. It's F. Is it the E? No, it's no E. It's no E. And is it a D? Yes, it's a D. And is it a C? Yes, it is a C. And is it a B? No, it's not a B, but it is a A. Yeah. You see the bit button? This is the bit button for the human readable things. And this is number 5. LED 7sec 6. What is 6? 6 is 6 is a F. No, 6 is a F. That's another H. H is no. It's a G. Yeah, it's a G. Then it's a F. It's a E. It's a D. It's a C. Not a B. And it's a A. It's number 6. Number 6. We need it 1 times and then we can change this. LED 7segment 7. It's 0B0 and is it a F? No, it's not a F. Is it a G? It's a G, it's a F. No, it's not. Is it a E? No, it's not. Is it a D? No, it's not. Is it a C? Yes, it is. Is it a B? Yes, it is. It is a A? Yes, it is. Now you look at the 7, it looks like so. Okay. And we say number 7. Okay. And then 8. We have 8 here. LED 7sec 8. It's a 8. 8 is all the things. It's with all, yeah. Number 8. And now we have the last one, I think. LED 7sec. It's 9. And we have 0. What is 9? Is it a G? Yes, it is. Is it a F? Yes, it is. Is it a E? No, it is not. Is it a D? Yes, it is. Is it a C? Yes, it is. It is a B? Yes, it is. And it is a A? Yes, it is. Okay, it is this. Number 9. Okay, and now we have a hex numbers. Hex numbers are running from 0 to F. That means we must also define LED 7seg A. Okay, we must define the A, and the A, it's near all, but with not a D. Character A. It's a big A. Yeah. Now we say LED 7seg B. Is it the B is FGEDC. FGGF. It's F, it's E, it's D, it's C, B and A no. Okay, this is the character B. Okay, in real it's so. You can see that. Put it a little bit in the middle. You can see it. Now we have the equation. I hope so that your LCD TV are also 7 segment, and this is number C. Have also this. We're making a countdown from F or 9 and so on down. Or we're making a counter. We're making a counter and the countdown is also possible. Now we're making a C. So this is C. AFED. AFED. No G, a F, a F, a E, AFED, a D, C and B not and A. This is the character C. Yeah. We also can have it here. LED 7 segments, and this is the character D. It's like 0B0. Okay, we have a D. A D is G, G, no F, E, D, C, B. A is not. We were wondering that the character is not working correct or so. E, and then we have a E. A E is also this, but no B, no C. Equal LED 7 seg. It's a E. Zero B zero. All, but all is on, but B is not and C is not. This is the character E. And then we have the F. The F is simple. LED 7 segments. It's a F. It's 0B0, no point. And what does that mean? It means following. It means the same than the E, but without a D. 1 1 1 0 0 0 1. This is the F. You can see this bit, the D bit, this is here, not flashing. It's the F. Okay, and this is the character F. Okay, so we defined this 7-segment pattern. It's complicated, but now we have the bit pattern here, and we must analyze the number, what's happened with this in a call. Yeah, and we go to our call station. Here is the call LED counter. We write here a program, and this program called like rcall LED 7-segment. Okay, this is a subroutine number 3. Okay, we take this and we take this and make a label. Okay, here we make a label, and here we say this is the 7-segment LED routine. Did you can see this? Oops, what is now? What is now? Where's my screen? I must insert it here. Oh, it's not copied. It's not copied. I don't know why. LED 7-segment. Okay. Double point. Okay. Here we have a level. What we're gonna do first is we say we need the information, and this information you like to copy to the temporary register or to the temporary 2 register. That we move one in temporary 2, and this is the counter here. From here we get the counter upstairs. Here. Where is my counter? Counter for the LED time. No, this is not. Blinky counter. No, this is not. Counter value. Counter underline LED. Counter LED. Okay. Counter LED. We say counter LED. We take the counter from the LED. It depends now on the LED counter. Taking the counter LED, and now we must mask it out. Yep. This is we making an AND. Yeah, an AND, a logical AND. And this is important that we do that. Must make now a mask out. That means we're using a command that's called ANDI. Yeah, and immediate. That makes an AND between the temporary 2 register and our mask low digit. Okay, what does that do? It mask out the low byte, 4 bits. Okay, we don't have this mask low digit. We must also say here numbers and names. We must say here it's equal mask low digits is 0B 1 2 3 4 1 2 3 4. Low nibble mask out. What is this? For short information, it's for 7 segment counter low byte. We must mask it out the counter for comparement, because we have only the thing that we mask out this, and we also must, for the compare, we must need here also the numbers to compare. This is 2. Yeah. And it's 3. Is 3, 4. We need the numbers in numbers. These are, you see, this is a single number. And normally in a byte you have 2 numbers. But the thing is that we have here 5. 5 is wrong. It's written like D5. 5. Okay. I'm sorry for that. What is this? X5. And this equals 6. And here X are 6. And this 7. And we must also define this, and it's 8, and it's 9, equal 9. It's 0x09. And we have here a char A, character A, B, C, D, A, F, and so on. Char A, we go here making a copy, paste. No, what went wrong with paste? Would like to this is U. Okay, I must mark this, and then what I'm gonna do, I make a copy with M6. And now I can insert it with Control U. It's empty. MA. I understand this. MA. M6. Okay, and now MU. How I can copy M6? It's copied. Nothing copied. How is that working? I'm very surprised that I don't understand this. Okay, I must go do this by hand. Equal character B equal character C equal what's happened now? Character D you if you program this in C, it's very faster, and you have nothing this definement. It's 0XOB. It's 0XOC. You understand this? Why we do this? Because they are in the program are not allowed to writing any characters or any numbers. If you would like to change the program DE, you learned it now. You're making all a definement for all, also for the characters and for the numbers. Yeah. What we're gonna do now? We analyze what is in the counter. Correct? And we mask this out. What does that mean? If, for example, it's standing mask out, what is this? For example, if we have in the mask out, we have in temporary 2, we have here standing this bit combination, for, and we mask it out with mask low digit, then temp2 is 0x04. That means that this character will be x'd. Yeah, it's gone away. So we make a detect. We say detect 0 or 1. No, we detect 0, and we said we compare immediate temporary 2 with now so is temporary 2 a null? And detect. Okay, is it a null? And we say, okay, if it's a null, then it should load the button null. Okay, that means it should load the button null and bring it out to the 7-segment display that the human can read this bit binary counter. This is an important thing. Okay? And that we're gonna do in case of we have this. Yeah, okay. Good. And what we're gonna do if it's not okay, we say branch is not equal to detect 1. Okay, should we write it so that is better readable? Yeah, we write it so that is better readable. If not equal, then jump to the next detection. Okay? If it's equal, then it's running in this, and we must set the button. Okay? We say we say we say out board B, and now LED 7seg0. Is that correct? Out the bit button to the board B for display for the 7-segment display. Okay. Good. But what we must close is we must close here this. We must here close this. We must disable the out pins for here. And we say now increment, delete counter increment. We said decrement. What is here? The D counter. Okay. We say decrement counter 2. If the counter 2 equals jump to a counter increment. Okay. We say we decrement it because we counting from we counting for the countdown. We count from up to down, okay, for the countdown. But we do not allow that it's writing out to the board. Yeah. Disable this in case of the bit button for the 7-segment LED. Okay. Now we have that out and we jump to the end. Jump LED segment end. Okay. We say LED 7-segment end. And here we put the return. Here's the program end. You can see that. But now we must do that with all the detection. Yeah, it must be run over all 16 detections. And now we need to know how to copy it. Copy this all the time. I'm doing this now because it's all the same. I can say you detect underline 0. If it's not here, then it detects. Okay, compare immediate temporary 2 with 1. We say temporary 2, this is 1 request. Branch if not equal, detect 2 to the next. If it's not the same, detect here. And if it is so, then say out board B, say LED 7 segment 1. Out the bit button for number 1. Okay? And R jump to the end. 7 segment end. Jump to the end. Okay? And this we must repeat now from 0 to F. It's 16 times. So I copy it often and I change it now detect number 2 to detect number 2 and branch detect 3. And here we have the 2 and we must change it. Is it 2? Change all this. And here we must also say 2. And here we go, making 3. Detect 4. 2, 3. Okay, we 4, 5, 6, 7, 8, 9. And here we must check it up. Okay, we do this till 9. Very funny. We must detect to do 4. Okay, then we jump to 4. We must detect jump. No, we load 1, 1, 1, 1, 1. This is wrong. Compare with 2. Compare with 3. Detect F. Okay, if it's F, punch is not equal, then on the end, okay? Double point, so character F. If it's F, it's okay, load the segment F. Out. And I'll jump to the end. It must not be. This must not be because the end is here. You don't need to jump. Okay. Now it should work. We must store it and assemble it. Control O, store it. I thought I would like to make it with this, but we have here an error in the system. These LED 7 segments are right now for the level here. LED 7 segments, this is with the level. The level and the register are the same name. And that we don't need this. I think I thought that we're making another board, and so we have it here stored in a register, but it's not happened. So we clear this, please, to fix this error, and we go again on this, and we save it. The problem is that out you can only do from a register. That means we have the problem that we must insert here a move to here. We must move or we must load immediate to temporary the LED 7sec0, and then we can put it out and send it to the temporary. We can only send from a register, and this is not a register, this is a value. We load the value into a temporary and send it out. And this we must do again and again and again. Yeah. 7segment and D temporary. Now you know why we have so much temporary registers. Character E, D, E, load immediate temporary register with what? With LED 7seg E A E. Put them out. Here we have the F. Normally it should be F, but we compare it for your. Did you understand what we're gonna do here? Temporary with LED 7seg F with the bit button and send the value from temporary to the board out. So now it's finished. We must assemble it. 2 errors are available. The first was the character F and the number F. Here we have the problem. Now it's correct, and it's making an error on the F and on the button digits. Okay, digit. Now it's digit written on there, you know. Blinky detect. Here is the digit. Now it's correct. Now we assemble it again. What we also gonna do is we change the timing from 100 milliseconds to 500 milliseconds. Why? Because a half second for a timer is okay. Normally it should be 1000 milliseconds, but we do it by 500. Half second is the timer, but we must also define it upstairs. Where is the counter defined? And where is the counter defined? Here it is defined. We say equal LED 500 milliseconds time and is 0x what? 100 microseconds are A. How can 500 be? Maybe we use the calculator. A, it's 10, and then it must be 50 to change to informatic. 50 is 80. 50 is what? 50 hexadecimal. No. Decimal is 50. 32. You can read it here. It's 32. It's 32. We say it's 500 milliseconds is 50 times its x32. And this is the 7segment count the time. Count down time. Count down time. Okay. we put it here. Now I'm in the assembly, and we say AVR assembly, the 7-segment assembler, and we get a list file, 7-segment assembly to the LSD. Bam! And what does it mean? 159 words. Okay, we say ls minus l. So we have here the 7-segment. Also here we have the hex file. Yeah, we would like to show the hex file. We say cat 7 hex. So the hex file is here, and we would like to do this playing it in, and we load it. I don't remember the word. Now we have the assembly code, and we just can cut AVR do the commands, and I forgot these commands all the time, and so we saying AVR AVR dude minus P M328P minus C, and we have the AVRESP MKEE minus verbose minus erase minus U flash. We flash the flash and write, and we have 7-segment, and this is the hex, and I think it's Intel hex, and we say minus B, we say minus B4. Okay, so we start the code to assemble it, and we read it. What is happened now? Cannot read serial sending control. Maybe it's the wrong machine or so. Oh my gosh, it's complicated now. I must searching this failure, and I come back if I fix it.
What we can see now here, the assembly, I fixed the assembly problem. It was a character problem. I wrote a wrong, not a W, a G, and G, no function. Yeah, what we're gonna see now is the countdown from F to 0. And on the left side you see here the pattern what we programmed. These are the bit pattern, and here are the numbers for the bit pattern. We can read it now. F, E, D, C, D, A, 9, 8, 7, 6. Running a little bit fast for a human being. And we count down the bits, and on the left side you see the bit pattern. Which character have which bit pattern. Now we can read it. We can read the digital numbers. And this is important to know for near coming user interface. Maybe we build an amplifier with an input for a high fidelity machine, and also we can use this controller for programming a interface for the human. Also, this is what I would like to do the next step, and would like to make maybe 2 characters or 2 digit, or we're making an input selector with a rotary switch is also possible. Yes, and we have a lot of things to program, and this is maybe in 10 times that we can do that. And have fun. I also would like to mention it, I give that free for download. I give you the link in the subscription, and there you can download the countdown. This is the first thing. The other things you must program by yourself or copy it out of this software. This is also no problem. The grid, I wrote also sub 3 in this, mention it sub 3 or sub 2 or so, yeah. And yes, that was the assembly countdown. you see that you must work long on it, and you can copy it down. You can download it. I give it in the address free, and I upload it in my Git account, so in the GitHub, so you can download it there. Yeah. I wish you all the best for the programming time, and we would like to make an interface for a selector. It's also maybe a hardware, and Paul requesting me in Canada. Hello Paul, it's a video for you. He requests me how to program assembly, and it's from the 80s and 90s. Long time ago. Yes, I forgot a lot of things like the temporary register and a lot of things to do what we can make, and yeah, so we can make an input selector. Also, we would like to program a shifter and the shift register and maybe LCD or so. It's also interest for you, and you can then build your own amplifiers and your own selectors. To make a CD player, it's much complicated, and it's difficult to make it. This is near high end. It's not 40 years ago, but this is the real high end, yeah, to make this to work. If you like my channel, please subscribe, and I say thank you for watching.